Hello, my dear friends. I am Soham Jagat. Welcome you all in science class. In last lecture, we have seen chapter number 10 and we completed theory portion of chapter number 10. Now, in today's session, we will see chapter number 11, that is work and energy. Chapter number 11, that is work and energy. We use term work and energy in our everyday life. We say that I have lots of work. We say that I am feeling energyless or I am feel energetic. But there is a whole different meaning of work and energy in terms of physics. So in this session, we will see what is the meaning of work and energy in science and particularly in physics. So let's begin this lesson. Chapter number 11, work and energy. In previous chapter, we have talked about ways of describing the motion of the object, the cause of motion and gravitation. In our previous chapters, that is chapter number 8, 9 and 10, we seen different kind of motion due to gravity and how to describe this motion. Another concept that help us to understand and interpret many natural phenomena is work. In science, we are try to interpret natural phenomena. So we have another concept called work to understand this natural phenomena. Closely, closely related to work are energy and power. We should remember this. We have another two phenomena or say quantity which is closely related to work, that is energy and power. In this chapter, we shall study these concepts, and in this chapter, we will going to see work, energy, and power. All living beings need food. Living beings have to perform several basic activities to survive. We know that to survive, we need food, water, oxygen for breathing, like for any other animal and living being. Food is necessary and we perform several basic activity to survive. Digestion, respiration and all other necessary activity which cause us for survival. We call such activities as life processes and we call such activity as life processes. That is one of the chapter in biology in standard 10 science. The energy for these processes comes from the food. We are working whole day. If we are not working, ideally, if I said I am sitting here and I don't do any kind of work, do you think I am not consuming energy? I am consuming energy at the time of sitting only, at the time of sleeping also. I consume energy. My blood is flow in body. I am respirating. So this minute to minute activity required energy. So we need energy for other activities like playing, singing, reading, writing, Thinking also needs energy. You might feel sometime if you read or revise subjects or hard subject for more time, you will feel energyless. It means that thinking needs energy. Jumping, cycling, and running. This all physical activity needs energy. Activity that are strenuous required more energy. Some activity required more energy while other required less energy. Animals too get engaged in activities. Animals have their own activities. We have our own activities. Like that, all living beings on earth has its own activity. For example, they may jump and run. They don't have school, tuition, reading, or any other activity. So what they will do? They jump and run. They have to fight, move away from enemies. For their survival, they need food, protection from enemies. So they have to fight, move away from enemies, find food or find a safe place to live. They have to find food and find safe place to live. Also, we engage some animals to lift weight, carry loads, pull carts or plow fields. Nowadays, we are doing all this activity using machines. But in previous year and also in some of area nowadays we are using animals to all this to carry out all such activities. Think of machine. List the machines that you have come across. What do you need for their working? We have machines. To run these machines, we need some energy. Why do some engine require fuel like petrol and diesel? Why do living beings and machine needs energy? We seen that to carry out our day-to-day activities, life processes, and for survival, we need to do work. And for that work, we need energy. And we get this energy from food. And machines get this energy from petrol, diesel, electricity, gas, etc. Work. What is work? There is a difference in a way we use the term work in our day-to-day life and the way we use in science. As we discussed earlier, there is a difference in work we use in everyday life and work in terms of science. Now we have our topic 11.1.1. Not much work in spite of working hard. We have example. Kamli is preparing for examination. She spends lot of time in studies. She reads books, draw diagrams, organizes her thoughts, collect question papers, attend classes, discusses problem with her friend and perform experiment. So this is procedure for preparation of exam, what kind of activities she is doing. She expends a lot of energy on this activity, and obviously to do all such things we need energy. In common parlance, she is working hard. We can say that she is working hard. All this hard work may involve very little work. All this hard work involve very little work. If we go by the scientific definition of word, if we go by scientific definition of work, what we said, all this hard work may involve very little work if we go by scientific definition of work. Now we will see what is the scientific definition of work. You are working hard to push a huge rock. Let's say rock does not move despite all effort. You get completely exhausted. However, you have not done any work on the rock as there is a no displacement of rock. This is the very important example to understood what is work. If we are push huge rock or say wall, can we move wall or a huge rock by our muscular force? No. Does it mean that we don't spend any energy on it? No, we spent a lot of energy on it. If we completely exhaust but still wall or huge rock will not move from its place. So by scientific point of view, our work done is zero, or work done on rock will be zero, because there is a no net displacement in rock due to our muscular force. So there is a no work done by us on rock because no displacement of rock. We should mark it. There is a no work involved in this case because there is a no displacement of rock. You stand still for a few minutes with a heavy load on your head. You get tired. If we get heavy load on our head, we get tired. You have exerted yourself and spent quite a bit of your energy. In this case also, we use energy to maintain this load on our head. Are you doing work on the load? The way we understand the term work in science, work is not done. In this case also, if I take heavy load on my head and after some time I get exhausted, after spend lot of energy for holding this load, I am not doing any work. So there is a difference in word work we are using in our everyday life and we are using in terms of science. Another example, you climb up the steps of staircase and reach the second floor of building just to see the landscape from there. You may even climb up a tall tree. If we apply the scientific definition, these activities involve lot of work. Here we have another example. To see a scenery, we climb on tree, or Say we reach to second floor of building to just see a scenery or particular place. In this case, we done lots of work. How we will understand it by example and definition in our this chapter, but after few time. In day-to-day life, we consider any useful physical or mental labor as work. As we mentioned, as I said, I do lots of work today, but there is a chance that I don't even work at all by definition of science. This is general term. I do work, that is general term. But according to science, I may or may not work as I said. In day-to-day life, we consider any useful physical or mental labor as work. Activities like playing in field, talking with friend, humming a tune, watching a movie, attending a function, sometimes not considered to be work. But in some cases, science does not consider all this activity or some of this activity as work. What constitutes work depends on the way we define it. What constitutes work depends on the way we define it. We use and define the term work differently in science. We use term work whole differently in science. To understand this, let us do following activity. What is the meaning of activity or say work in science? Let's do one activity, activity number 11.1. We have discussed in the above paragraph a number of activity which we normally consider to be work. We discussed many activities that normally we called it as work in our day-to-day life. For each of this activity, ask the following question and answer them. To consider it as work, we have to ask following question to particular activity. What is the work being done on? What is happening to the object? Who or what is doing the work? We have to ask all this question to our activity. What is the work being done on? What is the work being done on? For example, if I am trying to move any object, let's say table, I am trying to move table. So I can say that I am doing work on table. What is happening to object? Consider I apply force on table and I have sufficient energy to move this table. So I can say that table is slip aside, or I can say that table is moving 2 foot, or table moved by 2 foot. Who is doing the work? In this example, I am doing work because I apply force on table. So this is the some question we have to ask when we are doing any activity. Let's say if we are reading, is there any displacement? Is there anything doing by us on book? Sometimes we do work while we are reading because we turn page, we lift book, that all contains work. But our thinking process, in that there is a no displacement or no application of force. Science, or particularly physics, does not consider as work. Now, scientific conception of work. So till now we discussed that this is not work, this is not work. So now we have to understood that what actually scientific concept for work. To understand the way we view work and define work from point of view of science, let's consider some situation. To understand work in terms of science, we take some situation. Push a pebble lying on a surface. The pebble moves through a distance. You exert a force on pebble and pebble got displaced. In this situation, work is done. Let's say we have a pebble on a surface and we apply force on pebble. What will happen? It travels some distance. So in this situation, the pebble got displaced. Displaced means it changed its position. It changed its position. So pebble displaced. In this case, we can say work is done because we apply force, and by this force object displaced. So in this case we can say work is done. Another example, a girl pulls a trolley and trolley moves through distance. The girl has started a force on the trolley and it is displaced. Therefore, work is done. Again, same situation. A girl pulls a trolley, which means girl apply force on trolley, and trolley moves, which means trolley displaced, which means that the work is done by girl. Lift a book through a height. Lift a book through height. To do this, you must apply force. We have to apply force to lift the book. The book rises up. Therefore, there is a force applied on the book and book has moved. Hence, work is done. Another example, if we lift a book, we have to apply force. And by application of force, there is a displacement in book, change in position of book. So we can say that here I do work on book, and in this case work is done. Closer look at above activity or situation reveals that two conditions need to satisfied for work done. From above example, we can see that there is a two common thing for work done. Number one, force should be act on an object. Number one situation, force should act on object. Second, the object must be displaced. Object must be displaced, which means object should move from their initial position to final position. So we have to mark this point. To do work or To satisfy scientific definition of work, we need two things. One is force should act on object and another is object must displaced. So we have two important condition for work done. If any one of above condition does not exist, work is not done. If we don't apply any force, then also work will not done. And by applying force also, object does not displace, then also there is a no work done. If any one of the above condition does not exist, work is not done. This is the way we view work in science. Now we can understand how we define work in science and how it is differ from word work which we use in our everyday life. A bullock is pulling a cart, the cart moves. There is a force on cart and the cart has moved. Do you think the work is done in this situation? Try to think in this activity. Ask two questions. Is there any force included in this activity? If yes, ask second question. Does object move by this application of force? If yes, then work is done. If no, then work is not done. So I hope you understood all this topic and basic phenomena of work. What is work? How we can say work is done or not? And what is the difference in term work we refer in our everyday life and work in terms of science? Thank you.